Everyone to this live podcast on Twitch where you can find the news from the research industry that how our researchers keep on researching on various domains and topics to keep our lifestyle more sustainable and more useful. So let's get started without sorry. Yes, these articles are posted on our website named postscientist.com. Is if you are willing to check it out, please check it out. Otherwise, it will be enough for you guys to get you update from this podcast and uh, get you update from the research industry. So let's get started without wasting any further time. The first topic of the day is atomic level 3D model shows us how gadgets work. Hmm. Although nanotechnology and material science are complicated topics for most of us, the research in the field is of great importance to almost everyone. Your digital gadgets, for example, are completely dependent on it. Totally, today, all microelectronics depend on semiconductors. These are materials that are not very good at conducting electricity, but you can add tiny amounts of other substances to them, a process known as doping. This improves the semiconductor performance so they are not so bad after all. If in the past we doped semiconductor and we saw that this drastically changed the electrical properties of the material, says PhD candidate Casper as Hunstead at NTNU's Department of Material Science and Engineering. This is all well and good. It's nice when something works, but beyond the fact that it works, we haven't always understood very much of why it does. This is especially true at the atomic level. Now we know much better how we can image the individual atoms, which previously used to be almost impossible to find. This gives us new insight and allow us to understand how they affect that material properties, says Hanstad. Why knowing why is important too. So what? Why on earth should we care about single atom and why something works? Isn't it good enough just to know that it does work? If this was the case, physicists and chemists would certainly have fun during the research, but the rest of us wouldn't benefit much from it, of course. Only when you know more about how something works can you manipulate the material and optimize it. Says Dennis Meyer, he is a professor in the Department of Material Science and Engineering at NTNU, who lead the project. This way, for example, you can make more efficient, environmentally friendly, or cheaper material for the job to be done. Or you can assign new properties to a material that you already have available with much greater precision. This is also key for developing future material for system technology. Often we want to introduce new functionality to materials. For that, we need to know exactly what role each individual atom plays, says Mayer. Advanced image technique make it possible. Hunstead and colleagues present the result of many hours of work using atom probe tomography APT in a recent article in our Nature Communications. APT is an advanced piece of cutting edge equipment that NTNU acquired a few years ago. The machine can provide a three-dimensional representation of what a material looks like, right down to the atomic level, explain Constantinius Hetzluglo. He's a senior engineer in the APT laboratory at the Department of Material Science and Engineering. Hunstead and colleagues utilized these outstanding capabilities to study a new type of oxide-based semiconductor to which very small amount of substance have been added to tailor its properties. Conventional microscopy techniques didn't allow us to observe how small amounts of additives position themselves in semiconductors, says Hunstead. The new result shows that the investment is the very best technical equipment such as this APT machine pays off enormously and makes groundbreaking research possible, shows the enormous potential. The research is still not exactly easy using EPTA either, but by bringing together colleagues with the different experimental and theoretical background along with hard and inspired work, the NTNU team has found solutions. This isn't just a wonderful achievement, it also shows the enormous potential of the APT technique for research field where it has not been applied before. It shows the unique opportunity we have thanks to the modern infrastructure available in NTNU Nanolabs and TEM Gemini Center, says Mayor. Hannestead has worked with ABD for about 3 years. He has carried out extensive correlated microscopy measurements supported by Antonius van Helvoort and Pud Eric Willem van Helvoort is a professor at NTNU Department of Physics and experts in high resolution electron microscopy, while Willem is a professor second at NTNU Department of Physics and senior researcher at SNTF Industry. Einstein and Mayer are enthusiastic about all the fascinating possibilities that have already emerged from their APD-based research and the novel perspective for the characterization of functional materials at the atomic scale. Imaging of individually titanium atoms mixed into a semiconductor. For their recent article, the research group looked at the oxide-based semiconductor ER-MnTiO3. For this purpose, their collaborator at the Lawrence Berkeley National Laboratory in the US added tiny amounts of the element titanium Ti to uranium magnet ERMnO3. With the atom probe, we can get a three-dimensional representation of how the titanium atom are positioned in the semiconductor, says Mayer. This allows us to link the new electrical properties of the material all the way down to individual atoms. Dr. Mohammad Zishan Khalid is a member of the team headed by Xavier Selbach, a professor at NTNU Department of Material Science and Engineering. He supplemented the experiment with calculation. These calculations provide further insight into the effects that individual atoms can have on the physical properties. One of the advantages of what the researchers have done is that they can use the method on many other substances as well. It is not just limited to the substance that the research team at NTNU has experimented with. The procedures and the results are of broad interest. They can extend our understanding of oxide based semiconductor and functional material in general. The research opens completely new doors, Mayor says. Cooperative approach, strengthen research. Many people from different departments at NTNU it contributed to make the scientific breakthrough possible. SINTEF, the Research Council of Norway, the Norway Micro and Nano Fabrication Facility, NORFAB, and the Norway Laboratory for Mineral and Material Characterization (MI-MAC), and the Norway Center for Transmission Electron Microscopy (NORTEM), and NTNU Nano supported the work. The researcher point out the collaborative effort nicely showcases the strength of the interdisciplinary research. It shows that what can be accomplished with a solid state of the art infrastructure. The details of how Einstein achieved such outstanding results are probably not easily digestible for most of us. But the link to the research article below will give you something to chew on if you want to dig in. Interesting finding. We are moving towards the next topic. Food deficit in Africa will grow in a warmer world. Hmm. Africa was one of the world's fastest population growth rate. Growth models projects the continent current population of about 1.3 billion people will nearly double to 2.5 billion by 2050, and it's likely to keep growing beyond that. At the same time, malnutrition is widespread in Africa. 21% of the population faces food insecurity, and the continent is especially vulnerable to climate change. Warmer regions are already experiencing desertification, and areas of low agriculture productivity are susceptible to climate shock from adverse weather, drought, flooding, and erratic rainfall. The combined effects of population growth and the climate change raise a serious question for the continent. How will Africa feed its growing populace in increasingly unfriendly conditions? In a study published in Earth Future, Beltran, Pena, and D. Ondraco applied the result from the agro-hydrological climate and the socio-economic models to access food self-sufficiency and climate vulnerability for 49 African countries under a scenario in which the global average temperature is 3 degrees Celsius above pre-industrial levels by later this century. They found that under a 3 degrees Celsius warmer climate, Africa will face a severe mismatch between population size and food autonomy. By 2075, food production in Africa will be able to feed only 1.35 billion out of an estimated 3.5 billion people, a finding that already accounts for increased agriculture productivity through improved irrigation and sustainable practices. Under this climate scenario, African nations will have to expand cropland and rely more heavily on food imports. Both approaches come with downsides. Cropland expansion carries potential disastrous ecological ramification, whereas reliance on imports would make Africa more susceptible to volatility in global food prices. The analysis indicated that Eastern and Western Africa will have the most significant import needs. The research also suggested steps to address the grim forecast, increasing the proportion of plant-based foods consumed and improved water storage, particularly in arid regions, can help mitigate growing food insecurity. For example, in addition, halving current food loss and waste rates could boost domestic food production and feed an additional 130 million people. Nevertheless, the researcher notes this solution will not eliminate projected food deficit on the continent. The second of the United States Sustainable Development Goals is to end hunger and malnutrition. This research suggests this goal may not be feasible in Africa under the current emission and warming paradigm. So these are the food deficit in Africa will grow in rising temperature in the area in the land, of course. So I mean, bad news for him and good news, whatever. Okay, moving on towards next topic. Seasonal change in a Antarctica ice sheet movement observed for first time. Hmm. Some estimates of Antarctica total contribution to sea level rise may be over underestimated after researchers detected a previous unknown source of ice loss variability. The researcher from the University of Cambridge and Austrian energy company NVO identified distinct seasonal movement in the flow of land-based ice draining into George 4 ice shelf, a floating platform of ice roughly the size of Wales on the Antarctica Peninsula. Use imagery from the Corporate European Space Agency Sentinel-1 satellites. The researcher found that the glacier feeding the ice shelf speed up by approximately 15% during the Antarctica summer. This is the first time that such seasonal cycles have been detected on land ice falling into ice shelves in Antarctica. The results are reported in the journal The Cryosphere. While it is not unusual for ice flow in Arctic and alpine regions to speed up during summer, scientists had previously assumed that ice in Antarctica was not subject to the same seasonal movements, especially where it flows into large ice shelves and where temperatures are below freezing for most of the year. This assumption was also in part fueled by lack of imagery collected over the icy continent in the past, unlike the Greenland ice sheet, where a high quality of data has allowed us to understand how the ice moved from season to season and year to year. We haven't had comparable data coverage to look for such changes over Antarctica until recently, said Carla Boxall from Cambridge Scott Pollard Research Institute (SPRI) and the study first author. Observation of ice speed change in Antarctica Peninsula have typically been measured over successive years, so we have been missing a lot of the finer detail about how flow varies from month to month throughout the year, said co-author Dr. Fraser Christie, also from SPRI, and prior to the detailed records of high speed made possible by this Sentinel 1 satellite, scientists wanting to study short-term variation in Antarctica wild ice flow had to rely on information collected by optical satellites such as NASA Landsat 8. Optical measurement can also observe the Earth's surface on cloud-free days during summer months, said co-author Dr. Thomas Nagler, Envo CEO, but by using Sentinel-1 radar imagery, we were able to discover seasonal ice flow change thanks to the ability of these satellites to monitor year-round and in all weather conditions. Currently, the causes of this seasonal change are certain. It could be caused by surface meltwater reaching the base of the ice and acting like a lubricant, as in the case in Arctic and Alpine region, or it could be due to relatively warm ocean water melting the ice from below, thinning the floating ice and allowing upstream glacier to move faster. Three seasonal cycle could be due to either mechanism or a mixture of the two, said Christie. Detailed ocean and surface measurement will be required to understand fully why this seasonal change is occurring. The result imply that similar seasonal variability may exist at other, more vulnerable sites in Antarctica, such as the Pine Island and Thwarties Glacier in West Antarctica. If true, these seasonal signature may be uncaptured in some measurement of Antarctica ice mass loss, with potentially important implication for global sea level rise estimates, said Bowell Boxell. It's the first time this seasonal signal has been found on the Antarctica ice sheet, so the question is its raises regarding the possible presence and cause of seasonality elsewhere in Antarctica are really interesting, said co-author Professor Anne Wills, also from SPRI. We look forward to taking a closer look at and shedding light on these important questions. Hmm. Okay. Moving on towards the next topic, because it's the news that's provided by you. That's provided by us guys. So yep. Moving on towards the next topic, new analysis of shipping emission reveals that air pollution has a larger effect on climate than previously thought. Let's see. A group of researchers based at Oxford University Climate Process Group has used novel methods of analyzing satellite data to more accurately quantify the effect of human aerosol emission on climate change. The results are published today in the journal Nature. Human aerosol emission have a cooling effect on the planet because they can make clouds brighter by providing extra condensation nuclei on which a cloud droplet form. Brighter cloud reflect more of the sunlight that strikes them, deflecting it from the Earth's surface. However, it is currently unclear how large this cooling effect is, particularly if the cloud brightness change cannot be seen in satellite images. This could be when the emissions are diffuse, such as from city traffic, or when there are winds that disperse them. The cooling effect offsets some of the warming effects of greenhouse gases and provides the largest uncertainty in human perturbations to the climate system. To investigate this research, a team analyzed data on ship emission as a model system for quantifying the climate effect of human aerosol emission in general. Sometimes when a ship passes underneath a cloud, its aerosol emission brightens the cloud in a long line similar to a contrail. These so-called ship tracks have been studied previously. However, the vast majority of ships leave no visible tracks. This was the first study to provide a quantitative measure of the impact of invisible ship tracks or cloud properties, thus this cooling effect. Key findings: invisible shipping tracks had a clear impact on the properties of cloud they polluted. Surprisingly, the specific effects were different to those of visible shipping tracks. Invisible ship tracks showed a smaller increase, roughly 50% less, in the number of droplets in the clouds, but the amount of water increased more compared to the effect of visible tracks. This implies that for a given increase in droplets. The increase in water is larger than thought, equating to a greater cooling effect. The same may be true for aerosol emission mode. Generally, cloud may react more strongly to air pollution than previously thought, getting brighter and having a stronger cooling effect. Hmm. Ship emission often occur in remote ocean environment and so provide unique opportunities to study the effect of aerosol in isolation of other human-induced factors that affected the climate. This new study, led by DeFil student Peter Menensen, used a global database of ship routes containing the location of almost all ships at a given time. More than 2 million ship paths over 6 years, combining this with historical weather observation. The researcher then simulated where all the ship's emissions were carried by the wind and entered the cloud. Studying these locations in satellite data allowed them to measure the number of droplets and the amount of water in the polluted and unpolluted clouds. Importantly, this method does not depend on the ship emission being visible in satellite images. According to the research team, the findings indicate that human health policies to reduce air pollution must be carefully considered when forecasting future climate change scenarios. In a recent study, the climate process groups also found that ship tracks reduced by around 25% almost immediately after the International Maritime Organization introduced strict new fuel regulation in 2020 to reduce air pollution caused by global shipping. This analysis used a machine learning approach to automatically measure more than 1 million visible ship tracks from satellite images over a 20-year period. Professor Philip Stewart, who leads the climate process group in the Department of Physics, Oxford University, a co-author for the study, said three techniques show the value of combining novel data science approaches with the huge amount of Earth observational data now available. They will allow us to transform the analysis of climate process in Earth observation from case study to global monitoring, providing entirely new observation constraint on our understanding of the climate system and future climate models. The study Invisible Track shows large cloud sensitivity to aerosol has been published in Nature. Hmm. Moving on towards next topic, next discovery. TESS discovers an old warm Jupiter-like exoplanet. Let's see. Going to be an astronomy topic. Let's see. Using the Transition Exoplanet Survey satellite, TESS in an international team of astronomers has detected a new old and warm Jupiter-like alien world orbiting a G dwarf star. The new found exoplanet, designated TOI 54442b, in the size of Jupiter, about 30% more massive than the solar system biggest gas giant. The finding is reported in a paper published September 29 on the Arxiv preprint server. TESS is conducting a survey of about 200,000 of the brightest stars near the Sun with the aim of searching for transition exoplanets. So far, it has identified nearly 6,000 candidate exoplanet test objects of interest, or TOI, of which 256 have been confirmed so far. Now, a group of astronomers led by Nolan Gravius of the University of Geneva in Switzerland has recently confirmed another TOI monitored by TESS. They report that a transit signal has been identified in the little curve of a metal poor G dwarf known as TOI 5442, other designated TYC 9086 012101. The planetary nature of this signal was confirmed by follow up observation with Corelli and high accuracy radial velocity searcher HARPS spectrographs. We report the discovery and characterization of the warm Jupiter TOI 5442b. The planet was first detected by TESS as two signal transit events at 75.6 days apart. The researcher wrote in the paper, the new found exoplanet has a radius of approximately 101 Jupiter radii and a mass of 1.32 Jupiter masses, which yields a density at a level of 1.6 gram per centimeter cube. It orbits its parent star every 75.12 days at a distance of 0.32 AU from it. The planet's equilibrium temperature was estimated to be 441 Kelvin. Therefore, the astronomer classified it as a warm Jupiter. The host TOI 5442 is of spectral type G3V, has a radius of about 1.06 solar radii and is 11% less massive than the Sun. The star has an effective temperature of some 5700 Kelvin, luminosity at a level of approximately 105 solar luminosites, and its age is estimated to be 10.8 billion years ago. Uh, the metallist. The metallicity of a TOI 5442 was measured to be approximate minus 0.21. Taking into account that TOI 5442 is nearly 11 billion years old, the researcher underlined that its exoplanet is therefore one of the oldest known long period warm Jupiters and one of the few with an age estimate. TOI 5442b is one of the oldest known warm Jupiter, and it's cool enough to be unaffected by inflation due to stellar incident flux, making it a valuable contribution in the context of planetary composition and formation study. The author of the paper concluded, given that TOI 5442b has a circular orbit, the researcher noted that it is difficult to predict the formation of migration pathway for this planet. They assumed that it likely formed via disk migration or in situ formation as other mechanisms that are more likely to leave a planet on an eccentric orbit around its parent star. Interesting, interesting. Moving on towards next topic. An expensive device that can harvest energy from a light, breeze, and store it as electricity. Scientists from Nanyang Technology Universities, Singapore, NTU Singapore, have developed a low-cost device that can harness energy from wind as gentle as a light breeze and store it as electricity. When exposed to winds with a velocity as low as 2 meters per second, the device can produce a voltage of 3 volts and generate electricity power of up to 290 microwatts, which is sufficient to power a commercial sensor device. And for it also send the data to a mobile phone or a computer. The light and durable device called a wind harvester also diverts any electricity that is not in use to a battery, where it can store to power devices in the absence of wind. The scientists say their invention has the potential to relapse batteries and powering light emitting diode LED lights and structural health monitoring sensors. Those are used on urban structures such as bridges and skyscrapers to monitor their structural health, altering engineers to issues such as instabilities or physical damage. Measuring only 15 cm by 20 cm, the device can easily be mounted on the sides of buildings and would be ideal for urban environments such as Singaporean suburbs, where already wind speeds are less than 2.5 meter per second outside of the thunderstorm. The findings were published in the journal Mechanical System and Signal Processing in September. Professor Yang Yuan, a structural engineer from NTU School of Civil and Environmental Engineering CEE, who led the project, said, as a renewable and clean energy source, wind power generation has attracted extensive research attention. Our research aims to tackle the lack of small scale energy harvester for more than target functions such as to power small sensors and electronic devices. The device we developed also serve as a potential alternative to smaller lithium-ion batteries, as our wind harvester is self-sufficient and would only require occasional maintenance and does not use heavy metals, which, if not disposed of properly, could cause environmental problems. The innovation has received interest from the industry. The NTU research team is also working towards commercializing their invention. The study, which prevents an innovation that could help cut down on electronic waste and find alternative source of energy, reflects NTU commitments to mitigate our impact on the environment, which is one of the four humanity grand challenges that the University of seeks to address through its NTU 2025 strategic plan. Riding the wind, the device was developed to harness efficient wind energy at low cost with low wear and tear. Its body is made of fiber epoxy, a highly durable polymer with the main attachment that interacts with the wind and is made of inexpensive materials such as copper, aluminum foil, and polytetrafluoroethylene, a durable polymer that is also known as Teflon, due to the dynamic design of its structure. When the harvester is exposed to wind flow, it begins to vibrate, causing its plate to approach to and depart from the straw pot. This causes charges to be formed on the film, and electrical current is formed as they flow from the aluminum foil to the copper film. In laboratory tests, the anti-developed harvester could power 40 LEDs constantly at a wind speed of 4 millimeter per second. It could also trigger a sensor device and power it sufficiently to send the room temperature information to a mobile phone wirelessly. This demonstrated that the harvester could not only generate electricity to constantly power a device, but that it could store excess charge that was sufficient to keep the device powered for an extended period in the absence of wind. Professor Yang added, wind energy is a source of renewable energy. It does not contaminate, it is inexhaustible and reduces the use of fossil fuels, which are the origin of greenhouse gases that cause global warming. Our invention has been shown to effectively harness this sustainable source of energy to charge batteries and light LEDs, demonstrating its potential as an energy generator to power the next generation of electronics, which are smaller in size and require less power. The entire team will be conducting further research to further improve the energy storage function of their device, as well as experiment with different material to improve its output power. The research team is also in the process of filing for a patent with NTU Initiative and NTU Innovation and Enterprise Company. Hmm. I mean, great finding, great research. We are mostly be happily available in the market very soon, and we are waiting for this product to launch in the market, and with companies, whatever the competition is, but it will be essential for many of the developing countries and the developed countries to use sustainable energy instead of traditional energy, which are fossil fuels and many other things. So, moving on towards next topic, discovery of new function of the cerebellum. Going to a neuroscience topic. Let's see. The cerebellum is known as primarily for regulation of movement. Researchers at the University of Basel have now discovered that the cerebellum also plays an important role in remembering emotional experiences. The study appears in the journal PNAS. Both positive and negative emotional experiences are stored particularly well in memory. This phenomenon is important to our survival since we need to remember dangerous situations in order to avoid them in the future. Previous studies have shown that a brain structure called the amygdala, which is important in the processing of emotions, plays a central role in this phenomena. Emotion activate the amygdala, which in turn facilitate the storage of information in various areas of the cerebellum. The current research led by Professor Dominique D. Guerdon and Professor Andreas Papastro Polios at the University of Basel investigate the role of cerebellum in storing emotional experiences. In a large-scale study, the researchers showed 1,418 participant emotional and neutral images and recorded the subject's brain activity using magnetic resonance imaging (MRI). In a memory test conducted later, the positive and negative images were remembered by the participant much better than the neutral images. The improved storage of emotional images was linked with an increase in brain activity in the area of cerebellum, already known to play a part. However, the team also identified increased activity in the cerebellum. The cerebellum in communication with the cerebrum. The researchers also were also able to demonstrate the cerebellum shows stronger communication with various areas of cerebrum during the process of enhanced storage of the emotional images. It receives information from the cynical gross, a region of the brain that is important in the perception and evaluation of feelings. Furthermore, the cerebellum send out signals to various regions of the brain, including the amygdala and hippocampus. The latter plays a central role in memory storage. These results indicate that the cerebellum is an integral component of a network that is responsible for the improved storage of emotional information, says the Quadvan. Although an improved memory for emotional events is a crucial mechanism for survival, it does have its downsides. In the case of very negative experience, it can lead to recurring anxiety. This means that the findings which have now been released may also be relevant in understanding psychiatric conditions as such as post-traumatic stress disorder. So these are the findings. These are the discovery given by this new article, that how many of the cerebellum are responsible for the bad and good image of our journey and where our past, whatever it is. So it's a more likely a approach to any other thing which is given by our brain, which is functioning by our brain, that how we can imagine things, how we can remembering things, how we can doing everything. So yep, moving on towards next topic. When ending approach, people choose the familiar over the novel. Hmm. When people believe that a door is closing, that they have a limited amount of time left to enjoy something, such as dining out or traveling, they gravitate to the comfort of something familiar rather than the excitement of something new. According to research published by the American Psychological Association, in eight experiment with nearly 6,000 total participants, researchers explored whether people tend to prefer novel, exciting experiences such as trying a new restaurant or familiar ones such as returning to an old favorite, and whether those preferences shift with the amount of time people believe that they have left to enjoy similar experiences. The research was published in the Journal of Personality and Social Psychology. Previous research has found that an average people tend to opt for novel and exciting experiences over familiar ones. They would rather enjoy a new movie that rewatch something that already been seen. For example, given equal access to both. However, study author E.D. O'Brien, PhD at UG Kutsuma Wendt at the University of Chicago Booth School of Business, suspected that perceived endings might affect those choices by nudging people to return to meaningful old favorite. In the first experiment, the researcher asked 500 online participants, 663 college and business school students, to read hypothetical scenarios in which they were given the choice between a new experience or a familiar beloved one, such as reading a new novel versus rereading an old favorite, or visiting a new city versus revisiting a city they loved. Half the participants were simply asked to make the choice, while the other half were instructed to imagine that it was the last chance that they would have for a while to travel or read a novel Overall, across the situation, participants in the ending groups were more likely to choose familiar activities compared with participants in the control groups. In the next set of experiments, the researcher moved beyond hypo hypothetical question to explore people behavior in lab and real life settings. In one, for example, participants were told they would be given a gift card to a restaurant and that the gift card needed to be used in the next month. Then half of the participants were told to reflect on how few opportunities they would have for going to restaurants in the next month and specific things that might prevent them from going to restaurants. Finally, participants were asked whether they would prefer a gift card to restaurant they did visited before or one that was new to them. Overall, 67% of the participants in the endings condition preferred a gift certificate to familiar restaurant compared with just 48% of those in the control condition. Finally, the researcher explored why perceived endings seemed to push participants towards familiar things. They found evidence that it was not simply because the familiar experiences were a safe bet the participant knew they would enjoy, but also because they were more likely to find those familiar things personally meaningful. Our finding unveil nuance to what people really mean by ending on a high note, said Winnett. Endings tend to prompt people to think about what personally meaningful to them. People likely like ending things on a meaningful note as it provides psychological closure, and in most cases, old favorite tends to be more meaningful than exciting novelty. The research is especially interesting because on the surface it runs counter to the idea of the bucket list, whereby people tend to pursue novelty things they have never done but have always wanted to do as they approach the end of life. O'Brien said, here we find that at least in those more everyday ending context, people actually do the opposite. They want to end on a high note by ending on a familiar note. The researcher noted that the finding could help people better structure their time to maximize their enjoyment of experience. For example, by visiting an old favorite attraction on the last rather than the first day of vacation, retailers and marketers too could take advantage of cafes slated to close for renovation might put more of its favorite dishes on the menu rather than try new item for sale. And perhaps according to the researcher, such psychological framings could be useful for addressing larger societal problems, nudging people toward repeat consumption by emphasizing endings and last chances could subtly encourage sustainable consumption by curbing the waste that necessarily accumulates from perpetual novelty seeking, Willett said. So these are the results of which is being given out by the researcher, and how these all things going on when people have ending approach, and he knows that he don't have enough time to live on this earth. So yep, moving on towards next topic, a new method to enable efficient interaction between photons. Okay, let's see. Photons, particles that represent a quantum of light, have shown great potential for the development of new quantum technologies. More specifically, physicists have been exploring the possibility of creating photonic qubits, quantum bits of information that can be transmitted over long distance using photons. Despite some promising results, several obstacles still need to be overcome before photonic qubits can be successfully implemented on a large scale. For instance, photons are known to be susceptible to propagation loss, that is, loss of energy, radiation, or signals as it travels from one point to another and do not interact with one another. Researchers at University of Copenhagen in Denmark Institute de Physics Fundamental IFF 6 physics in Spain and Rio Universitat Bochum in Germany have recently devised a strategy that could help to overcome one of these challenges, namely the lack of photon-photon interaction. Their method presented in paper published in Nature Physics could eventually aid the development of more sophisticated quantum device. We have been working on the deterministic interfacing of single quantum emitters, quantum dots, to single photons to over 15 years, and have developed a very powerful method based on the nanophotonic waveguides. Peter Lodwall, one of the researchers who carried out the study, told physics.org, we generally applied these devices of deterministic single photon sources and multi-photon entanglement sources, but another possible application would be to induce non-linear operation on photons. Lodell and his colleagues realized the first proof of concept demonstration of non-linear operation using individual photons back in 2015 when they investigated this effect further. However, they encountered difficulties in the thoroughly understanding the fundamental physics underlying this complex single photon and non-linear interaction. In our previous work, we found that the physics governing the non-linear interaction of pulses of light was remarkably rich and gave rise to some novel opportunity for constructing photonic quantum gates and photon sorters, Lodell said. We have carried out the first experimental study of nonlinear quantum pulses undergoing nonlinear interaction due to the coupling with a deterministically coupled quantum emitter. In the new experiment, the researcher used the efficient and coherent coupling of a single quantum emitter with a non-photonic waveguide to enable non-linear quantum interaction between single photon wave packets. To do this, they used a single quantum dot, a nanometer-sized particle that behaves like a two-level atom, which was embedded in a photonic crystal waveguide. In such a system, the coupling is deterministic, so that one photon launched into the waveguide is interacting with the quantum dot. Lodell explained, sending impulses containing two or more photon induced quantum correlation, since only one photon at a time can interact with the quantum dot. By controlling the duration of the quantum pulse, we can tailor these correlation and the interaction between the photons. Using the experimental method, Lodell and his colleagues were essentially able to control a photon using a second photon, which was mediated by their quantum emitter. In other words, the successful relies on non-linear photon-photon interaction. We developed a method to get photons to efficiently interact with each other mediated by coupling of two quantum dots, Lodell said. We think this could open new direction for making photon-photon quantum gates, which is the difficult gate in photonic quantum computing, a deterministic photon sorter device that are essential example for quantum repeaters. The new strategy introduced by this team of researchers could have important implication for both quantum physics research and the development of quantum technology. For instance, the method could open new possibility for the development of quantum optical devices, which also allowing physicists to experiment with tailored complex of photonic quantum states. We have a range of activities that extend the present work. Hannah Leigh Janik, another researcher involved in the study, told physics.org, on a fundamental level, we are looking at understanding more deeply how quantum states of light are affected by traveling through a single quantum dot, but we are also already forcing application of this quantum interaction. At the moment, Lodell, Leigh, Janek, and their colleagues are trying to exploit the non-linear photon-photon interaction realized in their recent study to simulate the vibrational dynamics of molecules. This could be achieved by mapping the vibrational dynamics of complex molecules onto the propagation of photons in advanced photonic circuits. A new method enabled by the scientists, by the researcher, to interact between photon layers and used in the laser application and many other application which is being used more likely in the energy kind of things which need energy, which required energy. So yep, or traveling energy, whatever may it is. But we are moving towards next topic. Study shows the creating highly performing cobalt free cathodes is possible. Hmm. Okay, let's see. Leon batteries, rechargeable batteries based on lithium ion, are currently used to power a wide range of electronic devices ranging from smartphone to portable computer, toys, wireless headphones, and electric vehicles. Despite their remarkable performance, these batteries are made using some unsustainable and expensive raw materials. The most notable among these materials is cobalt, which is used to create layered cathodes for Li-ion batteries. Because of the recent surge in demand for electric vehicles, cobalt is rapidly become scarce on Earth, also due to the rising demand from the technology and electronics industry. Research at Hanyang University and Pacific Northwest National Laboratory have recently shown that creating highly performance layered cathodes without using could in fact be possible. The paper published in Nature Energy could ultimately contribute to the development of more sustainable and affordable lithium ion battery solutions. Professor Sun and I have been working together on cathode materials for the past 20 years. Professor Chong S. Yoon, one of the researchers who carried out the study, told Tech Explore, with the increased depletion of CO and its supply uncertainty, we recognize that it is becoming increasing imperative to eliminate CO from Ni rich layered cathode NCA or NCM used in electric vehicles. So far, eliminating cobalt from layered cathode for lithium ion batteries has proved extremely challenging. This is because even a small amount of this material can significantly improve the structural stability of cathode, which in turn expedites the so-called lithium intercalation kinetics. This is an essential chemical process that ultimately enables high performance batteries. To overcome this limitation, some researchers have been exploring the potential of a cathode made of lithium neon X Mn1 X O2, arguably the most straightforward cathode free composition. Lithium neon iron MnO05O2 is a well studied co free cathode and with stable cycling stability, but it provides insufficient capacity for today's EV. Yoon said there have been attempts to increase the Ni content in lithium to increase its capacity, but the capacity problem remained unresolved. Without cobalt CO, with it is difficult to extract lithium from the host structure. Hmm. To overcome the challenge I encountered during previous attempts at creating highly performing lithium neon magnesium O2 cathodes, Yoon and his colleagues increased this cathode operating voltage from 4.3 voltage to 4.4 voltage. This allowed them to extract a large fraction of lithium from lithium O2, which simultaneously increased the energy density and power density at the battery's highest operating voltage to ensure that their lithium ion battery remained stable at 4.4 voltage, the highest operating voltage. The team then had to re engineer the battery's cathode microstructure and electrolyte. From our experience, we knew that introducing dopants and high oxidation states MOW, SBTA, etc., refines the primary particle size and stabilizes the dilithiide host structure. Yoon said, we took a heuristic approach based on our past experience to determine that doping the lithium cathode with one molecule percentage MO gives the best performance. Fluoroethylene carbonate was also added to the conventional electrolyte to support the electrolyte at 4.4 voltage and protect the cathode surface from electrolyte attack. 1 mole MO lithium neon magnesium O2 cycled 1000 times while retaining 86% of initial capacity, which is more than sufficient to meet the battery life specified by the electric vehicle manufacturer. The main difficulty that Yoon and his colleague encountered when trying to operate their 1% 1 mole percent uh, mo lithium O2 cathode at 4.4 uh, voltage was capacity fading during prolonged cycling, that is A loss of capacity over the, time that plug use or rechargeable batteries based on helium rich layered cathode to ensure that their battery had enough life to power device for a reasonable amount of time. The first had to resolve this capacity fading issue. The exceptional cycling stability of 1 mole percent MO lithium at 4.4 voltage is largely owed to the grain size refinement and cation ordering. Yoon explained MO6 plus ions tend to segregate along interparticle boundaries and inhibit grain growth during high temperature heat treatment, which is necessary to convert the hydroxide precursor to lithium neon monoxide O2 grain. Boundaries in the ultra fine structured cathode increase fracture toughness by deflecting cracks generated by the abrupt lattice contraction near the charge end. The grain boundaries in the researcher cathode can also act as fast diffusion path of for lithium ion, which removes local inhomogeneities due to their composition and suppress intragranular fractures. By introducing MO6 plus, the team was able to arrange cations in their cathode in a specific ways that intermixing lithium and neon ions. This unique design stabilizes the cathode structure when it is most vulnerable due to the non uniform extraction of lithium ions. Our findings suggest that developing a high performance cobalt free layered cathode is no longer an elusive goal. Yoon said the proposal 1 mole percent MO lithium O2 cathode cycling at a high voltage in an economically viable solution that is achievable with current manufacturing technology. In addition, by clarifying the intrinsic role of CO cobalt during the extraction of lithium plus ions from the host structure, this work offered a material design and criterion for selecting a territory doping element for ensuring the structural and mechanical durability of cobalt free layered cathodes. The cathode design and composition proposed by Yoon and his colleagues could guide future research efforts aimed at improving the general performance of rich layered cathodes. In addition, their work might pave the way toward the creation of highly performing cobalt free battery technology, which could be more sustainable and affordable than their cobalt based counterparts. For high performance EVs with a long driving range and improved safety, the next generation lithium ion batteries will likely be all solid state battery ASSB featuring helium rich cobalt free cathodes. Yun added, we are now investigating the possibility of applying the proposed cobalt free cathode to ASSB. Hmm, interesting. So once again, improving our lithium-ion batteries, who are responsible for the energy consumption in many are in our battery cells and battery applications. So yep, interesting. Moving on towards next topic, a 44-year-old perspective study how money brings hunter gatherers new choices. Okay, let's see. If you visit the Geohansi people of northeast Namibia and northwest Botswana, you will see families that make a living from a mix of foraging, government aid, selling crafts, and other ventures. Most people have some monetary income used to buy food, clothing, and other goods. Some of the very few with salaried government jobs may have cars and furniture. Mud huts stand alongside stone houses. Wealth is unequally distributed, and hiding behind some of that wealth is debt. Hmm. It wasn't always like this. Money is a new in Jew Huansi society. 2 generations ago, their economy was largely based on foraging, wild uh, plant and animal resources. Since the late 1970s, the Jew Hansi have moved into semi-permanent villages and engaged in a mixed economy that includes monetary income. Within money, however, come new choices. In a new study, Polly Windsor, research professor in the University of Utah Department of Anthropology and at Arizona State University, and Cindy Hinson, Ye Huang at Arizona State, explored how money changed the Jew Hansi society, something from the forager days like sharing meals and gifting with those with close family haven't changed. Other things like extended kinship, networks, and need-based community giving definitely have. We don't have what's going to happen next, Windsor says. I have seen a change in norms or conventions from having to share most of what you have to being allowed to keep your cash income and fill your own needs and then share what's left over. The study is published in preceding of the National Academy of Science, History of the Jew Hansi Bushman. How does a society function without money? Before money, the Jew Hansi economy was based on sharing and gifting. Says the someone kills a large animal, Vincent says, and there's plenty of meat. Well, he can give out that meat at a very low cost or to himself because it's going to rot anyway. But the reservoir who might be quite hungry and in need will regard that meat as a great benefit. The nomadic hunter gatherer society also distributed possession throughout their communities through gifting things to each other. The gifts serve to give information about the status of the underlying relationship, shared necessity, and strengthen social bonds. As each gift carried with it a connection between giver and receiver. This transition of gifting and sharing came together in a system called Hexoda, which defined the keen each Jew Hanse was responsible for caring for. In hard times, Jew Hanse could rely on or even live with this Hexoda partners in other villages up to 125 200 kilometers away from once at a time. In 1974, 69% of Jew Hanse possession had been received as Hexoda gift, but then money entered the society, setting off gradual cultural changes during the 1970s. Amid losses of Geohansi traditional lands, the government of Namibia established a homeland for the Bushmen called Nia Nia. Over the next few decades, the Geohansi began raising animals and crops on a small scale and began receiving government assistance for children and pensions for the elderly, as well as some employment in the district capital of Tunskwe. That government assistance is vital since families have struggled to provide basic necessity following the loss of their foraging lands. In addition to the government assistance, a resident at Neo Neo also harvests the devil's claw plant, which grows in the bush and can be sold to pharmaceutical companies as an analgesic, providing another source of income. So, before we go on, let's pause and reflect on the concept of money, going back to the concept of sharing meat from a large kill. That's a transaction that costs the giver little since they have too much to use and benefit the receiver greatly since they are in need. But if you bring money into the equation, now sharing money costs the giver the same as it benefits the receiver since the value of the money is fixed. Sharing is now more expensive. It also detaches the meaning of item acquired through social relationships, sort of like how gives a certificate to a bookstore doesn't mean the same as a book that someone chose from that store as a gift for you. For the Jew, Hanse, almost all their possession previously had come from a gift given with a social bond. Hmm. So the object, the gift, is never detached from the relationship. Vincent says all your material goods have some relationship embedded in them, while with money you just go to the store and you have got it and there's no social relationship. How many change sharing and gifting Between 1996 and 2018, Vincent surveyed the Geohans in near learning about their lifestyle and social networks. She compared this data, including surveys of more of where people possession had come from, with data she did collected in the mid 1970s when first visited them in Botswana. With the help of long-term Geohansen research assistant, Vincent continued gathering and analyzing data on how villagers spent their money between 2020 and 2022. She found most notably that the Hexado system of exchange in an extended kin network had essentially collapsed by 1997. The number of Hexado partnerships had fallen by half. By 2018, the system was essentially little more than a story told by elders. Why did it decline so rapidly? Previously, in hard times, a band of Geohansi would disperse and live with Hansro kin, contributing their hunting ability and gaining the resources of their host. Now, with permanent settlements and the food option offered by money, sharing with visitors become more expensive than it had been previously. And with cash, the social economy is changing. Geohansi respect each other autonomy to do with their money as they wish and to take care of their own family first. When I get paid, I do get many requests. One villager said, I tell my family and friends the first I will pay off my store debts and buy food and school uniforms and other goods for the family and for myself if no money is left. I tell them perhaps next time I can give them something. This is how I manage to have enough for myself, but keep my friends. Sharing and gifting haven't completely disappeared, but have shifted to reflect the new economy. Instead of sharing meat from large kills, which still happens, but such kills are rare. Communities share tea and sugar parties and extended family meals. Gifts are still given, but are now purchased instead of made, and gifting with distant kin, which constituted 23% of gifting in 1974, has fallen to 1% of gifting in 2018. How many change the social order? Unsurprisingly, the introduction of money created disparities in wealth. The few salaried government workers received significantly more money than other villagers and spent it on card houses, furniture, and other possessions that are out of reach of many Geohonsi. But perhaps surprising to Americans, money did not create other form of social inequality. Even through 90% of the highest paying government jobs went to men. For example, women pursued income through the other means such as harvesting devil's claw. There were no significant difference in the number of possessions purchased by women and men in any given year or residence, suggesting the little gender inequality. There were always gender equality, Windsor says, and sometimes people think that because men have more jobs, it will decrease, but it doesn't. The Geohansi value egalitarianism, she says, which means that each person respects each other autonomy to pursue economic activity that helps prevent social inequalities between different income brackets. Expensive stone houses, she says, are built alongside mud huts. No bushman hires another bushman to do the dirty work, Windsor says. If people try to gain political power, they have put down. I don't know how long this will last. You really can't say, but for the time being, very strong egalitarian principle are holding even though the material differences are great. Wants and needs, yes, money has changed Johannes' society. That doesn't mean the previous foraging lifestyle was ideal. It was marked by periodic poverty, anxiety, and food insecurity. Windsor says there are benefits in being able to purchase food, clothing, and other necessity, but what happens when needs have been covered and more thing that used to be wants become needs? When more become available, computer, fancy phones, and all these things, these move from being wants to being needs in our perception, she says. And it's what happened to the Geohansi as well. A certain amount of material goods to make them comfortable, clothing, shoes, etc., becomes need rather than just wants. And that's what money really does. It changes the society because it continually has more and more moved into the category of needs. This is something Windsor says she sees rampant in Western society, but by learning from the Jehans, she is being able to see it emerge from the very beginning of money entry into a society. What I don't see is the use of money to create social inequalities. That's not happening yet. She says, but the society will likely continue to change. Currently, there are no social institution that enable one Jehansi to employ another or enforce payment for service rendered. Neither are there institution to enforce payment of interpersonal loans. Although stores have been willing to extend lines of credit, introducing debt as well. So what I will have to see, says Vincent, continuing, has nearly 50-year study of Jehan's society is of some new institution developed to deal with money in the current situation. Oh, I mean, interesting, perceptive, interesting money making ideas, that how the local peoples are being gather money by doing small jobs and by doing these things. I mean, great, of course. So, as I previously discussed in the previous podcast, that we have started a newsletter for you guys, providing in the information that is not easily available on the surface web, and for those who are easily available, will be not going to subscribe it. Otherwise, if you are willing to check it out, please check it out, because for a sustainable business, we need this money, we need this funding. Or you can have a tip us. We will provide the many more links to you guys. If you are into that kind of if you are having a mindset that we can provide you this money and give us the information, then we never ever have a problem with anybody, with any organization. We never need to do certain types of things or propaganda types of things. So if you are please if you don't want to this website don't want it to be the propaganda website, then please subscribe to this newsletter. Otherwise, it's going to be again handed by those guys, which is converted this website into a propaganda website. So, and yes, we are updating our website too. So don't worry. Every link, every single thing will be provided, and also we are moving towards started a app where you can read those articles in your free time in your mobile itself. So yep. um, yes, at the end I just want to say, you guys keep researching, stay curious, stay healthy.